Welcome to this video on the transformation of linear, quadratic, and exponential functions. By the end of this video, you should be able to write the equation or describe the transformation to linear, quadratic, or exponential functions. So all of this should be review. We're going to go through and remind some of the vocabulary and then try some of the examples. All right, so for a line, when we're talking about the transformation, the parent graph is y equals x. So any transformation, anything different than just an x is considered a transformation. So when we write this in slope-intercept form, mx plus b, we're looking for is what's happening with the slope and the y-intercept that's going to make it different from the parent graph. All right, so if your slope is less than 1, okay, really we're talking about a fraction, between 0 and 1, you're going to have a vertical shrink, meaning your line will be flatter. Okay, it's going to be flatter. If your slope is more than 1, then you're going to end up with a vertical stretch, and the line will be steeper. Your slope will be steeper. Okay, the bigger the number, the steeper the slope. Fractions go flatter, whole numbers, more than 1 will go steeper. Okay, your b is your y-intercept. If the b value is positive, that means the entire graph will move up. And if your b value is negative, then the entire graph will move down. And if there's a negative sign in front, the line is reflected. And what that means for a line is it's a negative slope. All right, so that's lines. Then we have our quadratic. So the parent graph for a quadratic is x squared. Anything different from that is a transformation that's occurred. And so we generally, when we're looking for transformations, we want it to be in vertex form so we can look at each of these things. So remember, your vertex will be h and k. And notice when h is negative in here, the sign changes when it comes out. And that, so it will be an opposite movement than it looks like it should be. So if there's a negative sign in front of the a, the graph will reflect. If your a value is between 0 and 1, you have a vertical shrink, which means the graph will be wider than the parent. If your a value is more than 1, you'll have a vertical stretch, which means the graph will be narrower to the parent. It's very similar to our lines here. If you have a shrink, the line is flatter. And how that translates in parabola is it makes it wider because the outside arms are flatter. But if a is more than 1, you have a stretch, which makes the line steeper. It makes the arms of the parabola steeper, which make them narrower than the parent graph. For your k value, out here off the end, if your k value is positive, the graph will move up. If your k value is negative, the graph will move down. And then if your h is positive, so here's what I was saying before. Because of this negative sign in our formula, what happens, h is doing is opposite of what you're seeing. So if you see h is positive, what's really happened is you've written x minus a negative number, and that turns that to positive. So if your h value is positive in the equation, you're actually moving left. And if your h value is negative, you'll actually be moving right. Okay, so you can see there's some similarities between the two of these, especially like slope and the a are kind of similar. And the k with the y-intercept is pretty similar. And the same thing's going to happen again when we look at the quadratics versus the vertex, the exponentials. So our parent graph for our exponential is just b raised to an x, because remember the exponent for an exponential is in the variable for the exponential is in the exponent. So when we're looking at transformations, we're looking at the standard form, and if you look at this vertex form compared to this, they are very, very similar, and a lot of the same rules apply. Okay, the k value for an exponential function is the asymptote. That is that line that the graph will approach but never ever touch. If there's a negative sign in front of the a, the graph will reflect. If your a value is between 0 and 1, same rules, you're going to end up with a shrink. And meaning the graph will be flatter than the parent. If your a value is more than 1, you're going to have a vertical stretch. And the graph will be steeper than the parent. Same rules. If k is positive, the graph will move up. If k is negative, the graph will move down. If your h value is positive, the same rules as quadratic. Because of that negative sign in there, it's going to go opposite what it looks. So if h is positive in the equation, you're actually going to move left. And if h is negative, you're going to move right. All right. So we're going to describe some transformations and write some equations that have been transformed. Let's try these examples on the back. So looking at these examples, they'll tell you, you have to be told what you're comparing to. So in this case, we're going to say the parent graph is going to be 4 raised to the x. And then we need to describe what transformations happen in this compared with the parent graph. So let's take a look. We also have to identify linear, quadratic, exponential. Because the x is in the exponent, that makes it exponential. All right, so I made this handy little chart so we could look at it. Here's our exponential, because that's the one that has the x in the exponent. So we're kind of looking at each thing. Notice I didn't talk about the b value. I only ever talked about the a value on the exponentials. So we're not going to worry about the number that's right next to the exponent, because it should be the same as the parent. But the a would be actually in front of that. So in this case, a is 1, which is the same as it there. So we don't have any difference here. The only difference between these two is +3 on the end. And the +3 is in the k spot, and the k is the asymptote. So that means that graph is going to move up 3. All right, let's look at number 2. So our parent graph is just x squared. So that's going to make it a quadratic, because the degree of a quadratic is squared. So I'm going to use the one that's being squared. So I have my example of what it kind of should look like to help me. Now, compared to here, I'm noticing this does not have -3 and this does. So that's the h value. So when we talked about h, if h was negative, it meant the graph actually moved right, because what this says is x minus a +3. So what the value of the vertex is actually +3. So we're going to move right 3, and there's nothing else going on, so there's no other transformations that take place. All right, now we're going to describe some transformations here. If the parent graph is x squared, what are the transformations for this? So I'm giving you a whole new equation, and we're going to describe what's changed from x squared. All right, so because it is a squaring, that means it's quadratic. So when I do these, I always like to start on the left and walk all the way across. Notice there's no negative sign. Remember, the negative means we have a reflection. The 1/2 is not here, so it's a number between 0 and 1, so that is a vertical shrink. All right, that's a +2, so we're actually going left 2, and then down 3. Okay, so we addressed each thing that was different from the parent graph. This one had a lot. They don't always have that much. Take a look at number 4. If the parent graph is y equals x, what is the transformation for this equation? So how is this equation different from the parent? Okay, there's nothing being squared. The x is not in the exponent. This is a linear graph. That's y equals mx plus b is really what this says. So how is this different? We have a negative sign, so we have a reflection. The 2, that's different from the parent. It's a number greater than 1, so that's a vertical stretch. We'll just use stretch. It's a stretch by 2. And then the minus 4 is your y-intercept, so you're going to move down 4. All right, let's try a couple more. If the parent graph is y to the x, well, we just did one like that. Y to the x we said was linear. So this is linear, and we notice that x to the first, the degree is 1, which makes it a line. So how are these two different? The only thing that's different is this 1/2, and that will be a shrink by 1/2, meaning it's going to be a flatter line than the parent. Okay, number 6. If the parent graph is 4 to the x, what are the transformations here? So here we're just going to list them out. So this is the x is in the exponent, so it makes it an exponential. We have a reflection with the negative sign. We have a shrink with the 1/2, so we say shrink by 1/2. We have x plus 2. So remember, that's really x minus negative 2 because the formula has a minus in it. So we're moving left 2 and then down 3. All right, now we're going to write some equations where I'm going to give you the transformations and we're going to write the equation. So if the parent graph is 4 to the x, so that's going to be our exponential. So we're going to be using this bottom one as our model. We're going to have a vertical stretch of 3 and left 2. Okay, so if we're looking at this, the A talks about stretching. So we need to put something in for A, which there currently isn't anything in. So we're going to say 3 times 4 to the x. And then it says left 2. Left 2 is up here in the exponent. And remember, it's x minus a 2. So left would be a negative 2. So it would be x minus negative 2, which comes across as x plus 2. And there's no up or down or anything, so I don't have anything out here for k. So that would be my final answer for that one. So we had our vertical stretch of 3 and left 2, which in the equation becomes positive. All right, let's try our next one. If the parent graph is y to the x, okay, so that's a slope. That's a line, okay, mx plus b. Write the slope-intercept form of the equation with the following transformations. We have a negative slope, so we know we have a negative sign out front. A vertical shrink, we got to make a correction here. That's a 1/4, not a 4. Vertical shrink by 1/4, so I'm going to put 1/4 in the slope spot. And then up 2. So we have this x as part of the equation, and then up 2 will be plus 2. All right. Hopefully we're remembering a lot of this. It is a review. Now, if our parent graph is x squared, that makes it quadratic. So this is what we're wanting to model right here. Write the vertex form of the equation with the following transformations. We have a vertical stretch by 2. That's an a value. Stretches are a's, so I'm going to put it where the a goes. And reflect down. Reflect, oh, that's negative sign out front, down 4 and right 9. So my left and right goes in this parenthesis. Right 9, that'd be a positive number, so when it's in here, it's going to look negative. And then down 4 will be minus 4. You just have to be real careful because they're not always going to be written in the order in which they're going to go into the equation. You got to make sure you're putting them into the correct spot. Hopefully that was helpful. Let me know if you have any questions. See you in class.